Pre-calculus students. We're going to talk about reciprocal trig functions. Okay, so reciprocal trig functions, the reciprocal of the sine, so 1 over the sine of x, we're going to call the cosecant of x. So if we were looking at a triangle, if sine is the leg opposite over the hypotenuse, then the cosecant, so when you see SC, that means cosecant of x is hypotenuse over the leg opposite. Okay, the cosine, the reciprocal of the cosine is, we're going to call the secant of x. So secant, this is called the cosecant. I know you're wondering why the cos can't go together. I didn't decide that. I don't know why, but secant is the reciprocal of the cosine. So if cosine is usually leg adjacent over hypotenuse, then secant is the hypotenuse over the leg adjacent. Okay, and then cotangent is the reciprocal of the tangent. We're going to use COT to represent cotangent. So if tangent is leg opposite over leg adjacent, then cotangent will be leg adjacent over leg opposite. Okay, so we're going to be looking at the graphs of them, and we're going to start with the graph of the cosecant. And the cosecant is the reciprocal of the sine. So I have started with a sine graph, and you'll see over here, I have a little table. I just made the table. I got these values directly from the unit circle, and I just did it based on this scale right here. And the reason I want the table is because the cosecant is the reciprocal. So I want to find the reciprocal of all these values. So if I find the reciprocal of 0, so 0 is like 0 over 1. If I flip that, I can't divide by 0, so that's undefined. So anytime the sine is 0, the cosecant is undefined. Okay, when I have this root 2 over 2, if I flip it, it's 2 over root 2, which we could simplify and multiply the top and the bottom by the square root of 2, but really I'm just interested in graphing. That's equal to 1.41. So whenever I have a root 2 over 2, it's 1.41, or here I have a negative root 2 over 2, it's negative 1.41. That's going to help me with my graph. And then the reciprocal of 1 is just 1, the reciprocal of negative 1 is negative 1. So whenever I have undefined cosecants, then the way that's going to show up in our graph is that's going to show up as a vertical asymptote. So I'm going to draw in my vertical asymptotes. Okay, and these keep repeating every pi. So what you see I have over here, like how can we describe the graph? When we talk about the asymptotes, they're happening every pi, right? 0 pi, 1 pi, 2 pi. So multiples of pi. And that also kind of coincides with our domain. Our domain can be anything except for odd multiple, or except for multiples of pi, which we could call pi n, if n is an integer. This is supposed to be an R, like an R for all real numbers. My asymptotes then are happening at the vertical lines x equals pi times n. Okay, so now to get my graph of like what's in between, I'm going to plot these points. So at pi over 4, 1.41. So pi over 4, there's 1.5, 1.4. I want to be a little shy of that. Okay, and then at pi over 2, we're at 1, so that they intersect there. And at 3 pi over 4, we're at that 1.41 again. If I were to graph more points, right, like if I were to graph at pi over 6, it's at pi over 6, the sign is half. If I flip that, it would be 2. So what you end up with, it looks like basically a kind of a parabola through here, getting closer and closer and closer to your asymptotes. All right, and so then if we go and graph in this negative region, so at 5 pi over 4, 1 second.
Oh, very nice.